All right, so we have time to talk about the next topic, which is pointers and addressees. But before I do that, I want to make sure that you don't have any questions about this or this or that or the stuff that we did here. And if you want us to do another example that uses something that we covered here, then I'd like to hear that and we can do it. But if you feel that there's no need, then we can start with a new topic. I'll give you a few seconds to think about that. Think about, questions if you have any. If after a few seconds you don't have any questions, we can start with a new topic. All right. All right. Super. We can move on and start talking about pointers and addresses. Now, this topic you haven't seen in Python, even though it does exist in Python, but it doesn't exist in a similar capacity uh, as the one that we're going to talk about today. It also does exist in Java, but again, not really similar to what we're going to talk about today. So most likely the stuff that we're going to talk about now are new. So I'm going to try to be very kind of gradual, very slow, because I do want you to I do want to make sure that you have a complete understanding of this. And this can be tricky. I have to say that many students find this topic, rather confusing. So I don't want it to be confusing for you. And because of that, we're going to try to do it slowly and do as many examples as we need to. Okay. So if you remember yesterday, we said variables have names. Maybe we didn't say that, but that was something that we used. For example, here, this is the name of the variable. I know we did talk about variables having values, like in this case, var contains the value 0. And in this case, num contains the value 5. So variables do have names, they do have values. Now, variables also have kind of sizes. This is the spaces in memory that's allocated to these variables. So this is something that we also talked about yesterday. We did say that integers typically consume 4 bytes, characters consume 1 byte, floats consume 4 bytes, shorts consume 2 bytes. So each variable, depending on their data type, they're going to allocate some space in the memory. Of course, when we define it, we have to define it for it to allocate space in the memory. And the thing that we haven't talked about, which is super important in the context of this, is that variables have addressees. This is essentially the location of where the variables are stored. So right now, you know what I'm going to do? I'm going to open my Keynote because I think it'll be a very good idea for us to visualize kind of the RAM and kind of where variables would live and all of that. So the RAM, you can think of it as a grid. You can think of it as a matrix. Now we like powers of 2, so I'm going to do 16. 16 is a power of 2. And here I'm going to do also, I'll also do 16. So this is kind of a, right now it's a square. Okay. So your RAM is going to look like this. It's going to look like a matrix or a grid or a table. And it has kind of, it's a 2D space. So it has, again, a matrix or a table is a good description. And each cell here is going to represent a byte. So we do know how many bits a byte is, right? Do you remember how many bits a byte is?
8.
8, exactly. So essentially what you can think of this is that there is 8 bits here. So there is maybe 1, 2, 3, 4, 5, 6, 7, 8. Now, we don't care about the values of those bits. Let me actually change that to string or text. Let me make that small. And the idea is like here, maybe we have 1, 2, 3, 4, 5, 6, 7, 8. Can I make it smaller? Let me do that. In fact, let me make this 8 so that we don't have to make it very small. So here, there's a byte here, 1 byte. And this 1 byte is going to be 8 bits. And the values of all of those 8 bits is something. They could be all zeros, they could be all ones, they could be a mix. For now, we don't care. Let's say 1, 2, 3, 4, 1, 2, 3, 4. This byte is going to be 1, 1, 1, 1, 1, 1, 1, 1. This one might be 0, 0, 0, 0, 0, 1, 0, 1. That's okay. Now, when you say, I want to create a variable, let's say, for example, int my number. Now, this is an integer, right? Do you remember what the size of an integer is? How many bytes is an integer? Can you guess? Do you remember how many bytes an integer takes?
4.
4, exactly. So when you execute this one, what's going to happen is the compiler is going to say, I need 4 bytes in the memory. I need to allocate 4 bytes. Now, those 4 bytes have to be consecutive, meaning that they have to be next to each other. They could be here. They could be here. You know, there is actually restrictions. There are restrictions. So we don't want to, but for now, we don't want to think about those. Let's just say the only restriction is that they have to be consecutive, just to simplify things a little bit. So let's say they're here. Let's say I'm going to allocate the space here. I'm going to change the color of it. So that's going to be the 4 bytes. Now, to kind of talk about the addressees of those bytes, we do need to talk about the first byte and the last byte. So where is the first byte? Where is the last byte? How do we count or how do we number those bytes? And you can use different notations. The notation that we're going to use in this course is going to start at the bottom right and it's going to end at the top left, which means that the address of this byte is 0. The address of this byte is 1. The address of this byte is 2, 3, 4, 5, 6. Now, let me make sure that there is one thing that we agree on, because again, this can be confusing. That's why I do want you to ask me questions if you have any doubts about anything that I'm saying. Those numbers that you're seeing here, those numbers are the addressees. These numbers are not the values. So each byte has 8 bits. Each byte has 8 bits and there's a value. You can use those 8 bits to indicate the value, but also each byte has an address. So I'm going to say that one more time because this is super important. In the RAM, we have bytes. We have many bytes. We have millions of bytes, at least. Billions of bytes if you have gigabytes. Each byte has an address, and this address is going to be a number. And each byte has a value. And that value, of course, is the value of the 8 bits that are inside that byte. Let me pause here for a few seconds, make sure that that makes sense. You can give me thumbs up if that makes sense. All right. So now the question that I have for you is, how many bytes does an integer have? Well, I think you did tell me 4, right? You did tell me that it's 4 bytes. And let me take my integer. I don't want this number to be very high. So let me actually put my integer here. Now, here's something that I'm going to ask you, and something that we can think about together. If my integer is here, and if my integer is consuming 4 different bytes, and if every byte has an address, then essentially my integer has 4 different addresses, if you think about it, because my integer has 4 bytes. Each byte has a unique address. So because of that, maybe my integer has 4 addresses. And you might think that this is the case, and it's okay. It's actually not bad to think that this is the case. I need to tell you that this is not how, we think of integer addresses. We don't think of it as kind of all the addresses that are part of the bytes that are being consumed. Instead, we look at the first byte. So even though this integer has 4 bytes, and even though the addresses of those bytes are 12, 13, 14, 15, if someone asks you what is the address of this integer, which is 4 bytes, you have to say 12. So essentially what I'm saying here is the address of an integer is the address of the first byte of that integer. And this is really the case for any data type. So the address of a float, or the address of a long, or the address of a double, or the address of a character, or the address of a short, is the address of the first byte out of those, 4 or 8 or 2 or 1 bytes. Let me pause here and make sure that this makes sense. Let me pause and see if you have any questions about what I said. Okay. So let's say I have a short. Now, if you remember, short is 2 bytes. And if you don't remember that, that's because maybe you haven't seen the full video of yesterday's class. But once you do that, you will see that you will see that a short is 2 bytes and a character is a single byte. So here we can have a character. So this could be an integer, which has the address 12. This could be a short that has the address 16. This could be a character that has the address 19. That's all fine. That makes sense. That should hopefully make sense. Yeah. So let me see if there's anything I need to mention here. Yeah, I think that's good. I think that was a good introduction to how, the memory is broken down into bytes, and how bytes have addresses and how bytes have values. So don't forget that bytes have values. So even though I have a single number here, 12, this is really the address. But this particular byte has 8 bits, and those 8 bits have values that are, of course, not 12. 12 is just the address. It's almost like an address of a house. But what's in the house has nothing to do with the address of the house. Each house has an address. Each city has an address. And what's inside that house or what's inside that mailbox is really has nothing to do with the address per se. The address is, you can think of the address as metadata. It's data about the thing. And those addresses are data about the bytes, but they don't really tell us anything about what's inside the byte. Just keep that in mind. Don't forget that. So here, if we were to go back to my Xcode, when I do this, this one's going to allocate 4 bytes like this. Those 4 bytes are going to have values. Those 4 bytes are going to have addresses, but my variable here, because it's an integer, I mean, it could be an integer, it could be a float, but because it's a variable, it should have a single address, and the single address is the address of the first byte out of those 4 bytes. So of course I can give this a value. I can say my number is equal to 100. And you know what I can also do? I can print the address of that variable. So for me to print the value, I can just say print if the value of my number is %d\n, comma, my number. And if I want to print the address of this one, here's how I do it. Print if the address of my number is %x, because addresses are represented usually in hexadecimal, \n. Actually, I apologize. It's not x. We should use p. And I'll tell you why we use p in a second. But just bear with me here. And then I'm going to say, instead of my number, I'm going to say the ampersand of my number. So this is new syntax that we have to, remember. My number by itself is going to give us the value of my number. But if you say the ampersand followed by a variable, then this whole thing is going to be the address of that variable. And the address of that variable is of type pointer. So we talked about some types, right? So we have integer, short, long, double, float, character. All of those are data types. And there's another type called pointer, which is really contains an address for a variable. So pointer is another data type, and that's why we use the %p for pointer, and that's going to print the address of my number. And as you will see now, it's going to do it in hexadecimal. So let me hit play here. So this is the value of my number, and this is the address of my number. And again, this is the address of the first byte out of the 4 bytes that are used for my integer. So this single address will point us to the first byte out of the 4 bytes that we have.
Can you repeat what the pointer is?
So a pointer is a data type. So something similar to char, float, double. And pointers only contain addresses of variables. So if you have another variable here, let's say int, let's say cost, that's going to be equal to 300. When this executes, it's going to allocate 4 bytes. Maybe it'll do it here. Maybe it'll do it here. Because it's an integer, and the integer requires 4 bytes. And this has an address, and the address of this integer is going to be the address of the first byte. And you can take the address and you can put it in another variable, and that variable has to be of type pointer. So pointer is a data type that can contain a value that represents an address of another variable. And let me show you an example here, and hopefully that will make sense So I can say I want to get the address of cost and I want to put it in a variable. So you can say I want to put it in a variable here. And this variable has to be a pointer because the address of any variable can only live in a pointer data type. And for us to declare a pointer data type, we would have to do this int star, and then I can say pointer to pointer that contains address of cost. So I know that's a lot of things, but we can spend the remaining of today's class, and on Monday we can practice more. But essentially, this will give us the address of cost, and I want to put that in a variable. I cannot put it in an int or in a float or in a double or in a character. It has to be placed in a variable that has the type pointer. And this is how you declare a variable that has the type pointer. And the reason why we have int here is because that pointer is going to point to an int. Now, again, I'm going to spend the remaining of today's class talking about this, and we can do more of that on Monday. The pointer, this pointer that contains address of cost, is another variable, right? Just like cost, just like my number, it's another variable. So it would live actually in the RAM, and it would contain the value of this one, pointer that contains address of cost, is going to be the address of cost.
So if cost was a float, it would say float star.
Exactly. If cost was a float, it would say float star. So the pointer, there's no such thing as pointer. Really, the proper way to say it is a pointer that points to something. So let me add a few comments. Maybe that'll make things better. And let me just say P1. P1 is a pointer that points to an int. This is the same thing as saying it's a pointer that contains an address of an integer. And because it's a pointer that points to an int, it needs to be defined as such, which is int star then something. So let's say, for example, I have a character. Let's say I'm going to say char, my letter, let's say my L is equal to B. I can say char star, and I can say P2, and that's going to be the address of my L. Now, in this case, my P2 is a pointer that points to a character. That means this is the same thing as saying it's a pointer variable, let's say variable here, that contains the address of a character. Because it's a pointer that points to a character, we should define it as such, meaning that it should be defined as char star, then the name of it. Now, the value of P2 is the address of my L. This is very important to think about. So the value of P1 is the address of cost. So I think if we were to visualize it, it'll make more sense. But let me pause here and see if you have any questions. Do you have any questions about anything? Let me get rid of those. Okay, let me do an example here. Let me try to visualize things and hopefully it'll make more sense. So I'm gonna say here what is the color of this one? Can we make it red? Let me say red here. And I'm gonna say red is, in this case, cost. And what I'm gonna do is actually I'm gonna merge all of those. And I'm gonna put the number, which is really the value, which is 300. So the value of those 4 bytes is 300 because that's the value of cost. Are we good so far? Give me a thumbs up if that makes sense, because this is important. I'm going to try to summarize everything right now, and hopefully it'll make sense and everything will make perfect sense, hopefully. So this is what I have. Now I'm going to show you P1. However, I haven't told you how big P1 is. I'm going to tell you right now. You can guess if you want to. Do you want to guess? How big is the pointer, you think? How many bytes? It's a pointer, it's a data type, similar to int and character and short and long. If you were to guess, how many bytes do you think the pointer is? 1 byte. Not quite. It's actually 8 bytes. And we can talk about that more on Monday. For now, just know that it's 8 bytes. So all of that, which I'm going to use the color white for, is the pointer. So white is P1. And I'm going to also merge all of this. Now, here, what I'm doing is I'm saying the value of P1 is going to be the address of cost. So the value of those 8 bytes are going to be the address of this. Can you tell me what that value is going to be? What do you think the value of those 8 bytes should be? Think about it for a minute. The address, what would that be? What's the number? What is the number? What is the address of this one?
You're asking what the value of the pointer is of P1?
Mm-hmm. What's the value of P1? So Grace is saying 12, and that's correct. So it's 12 because the address of those 4 bytes is 12, right? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 9, 10, 11, 12. 12 is here. So the address of this byte is 12. So the address of this whole integer is 12. And because when you create a pointer and give it the address of another variable, essentially the value of this pointer is going to be the address of the other variable. So it's going to be 12. So what we did here, those 2 lines, this line and this line, is going to do this. It's going to first allocate 4 bytes for the integer, assigning the value of 300, then allocate 8 bytes for the pointer, and make the value of the pointer equals to the address of that integer. And in this case, it's 12 because we have it here. Does that make sense? Okay, that's good. Now, I know that you probably have many questions, like why are we doing this? How is that useful? This seems like a waste of time, maybe. And it's all justified. All those questions are justified, but we don't have time to answer those questions. We're going to answer them Monday. So what we did today, of course, we talked about loops and if statements and some integer division and using the or and. So we talked about many things here, but then we talked about this idea that variables have names, values, sizes, which actually we knew, but also variables have addresses. They live in the RAM and they have addresses, and the address of a variable is the address of the first byte of that variable. And then I introduced this idea of a pointer, which is another data type. And essentially a pointer is a variable that contains the address of another variable. Now, why we need such a thing, that's we're going to cover on Monday. That's kind of very important. But for now, I do want you to know that a pointer is a data type. A pointer typically is actually 8 byte long. And I'm going to tell you why that's the case on Monday. And the value of a byte, of a value of a pointer, is going to be the address of a variable. If you want to create a pointer that points to an integer or that contains the address of an integer, then that's how you would do it. Kind of int star, then you give it the name, and you say, I want it to contain the address of an integer. If you want to create a pointer that points to a character, then you would do char star, you give the pointer the name, and then you give it the address of that character. Let's actually do that really quickly. Let's say this is purple, right? That's going to be purple is my character, which is my L. I think that's what I called it here. So my L is purple, and this contains B. Of course, B is going to be a number, but we don't have to talk about that for now. But B is going to be converted to the ASCII code of B. But for now, we can just keep B here. In fact, let me get the ASCII code of B. That'll simplify things a little bit. Let me say ASCII of B. So the ASCII of B is 98. So 98 is the value. And of course, you can put 98 is in 8 bits. So that's perfectly fine. It does fit. 8 bits is more bits than what you need to represent 98. And let's say I have another pointer, and that pointer is going to also be 8 bytes, and I'm going to give it a color that I know the name of, like a gray. And I'm going to merge that. And let's say gray is P2. So let me do that. So this is P2. And because I said I want P2 to be the address of my L, what do you think P2 is going to be? Think about that for a minute. What do you think the value of P2 should be? $19. Okay, let's see. 12, 13, 14, 15, 16, 17, 18. Oh, wait a second. This is 11, 12, 13, 14, 17, 18, 19. Why am I confusing myself? Let's do it one more time. This is 11, 12, 13, 14, 15, 16, 17, 18, 19. So that is correct. Of course, you can just say it's going to be, 11 plus 8 because each row is 8, and that would be 19. So that is correct. So those two were defined or created when you execute these two lines. All right, so I think we can end it here. I know you probably have questions on why we're doing this, and those questions will be answered on Monday. But if you have any other questions about other things besides the why, you can ask them now, and I'll try to answer them. Okay. All right. So it seems that you don't have questions. Let me stop the recording. I do want to ask you something. Let me stop the recording here. I don't want to record that.